I wanted to do a brief refresher with you all with regards to section 2.4, which is graphs of equations. Specifically, what I'm going to spend some time on is the idea of transformations. So, say, for example, we work with the basic function f of x is equal to the absolute value of x. If we were to graph this, it would look like so. I'm going to set up a quick table just as a reference. An x and y table. And what I'm going to do is I'm going to work with values from -2 to +2. The reason why I'm picking these is because they're relatively quick to evaluate. You're going to run the risk of you're going to reduce the risk of making calculation errors. That's what I'm trying to say through my poor grammar. And what the other nice thing is that these values from -2 to 2, they help center everything. You're actually going to look at the dead center of the function for the absolute value. So we will go ahead and plug these values into the parent function. And a parent function, like I had said in class, means that the function doesn't have any extra bells and whistles. There are no shifts to the left, to the right, up or down. So we would take a look at this -2 and say, okay, to figure out what y is, I would plug that in to the function. And we would say, okay, well, the absolute value of -2 is +2, because absolute value measures distance away from 0 on the number line. So -2 is 2 units away from 0. And we would continue in that fashion. So the absolute value of -1 is 1, the absolute value of 0 is 0, absolute value of +1 is +1, and absolute value of +2 is +2. So we can go ahead and plot these points. Okay. So again, let's talk about now if I were to change this up. So instead of f of x is equal to the absolute value of x, this time I'm going to do the absolute value of x minus 3. And what I want you to note here is that the -3 is going to cause a shift. Okay? It's actually going to cause things to move downward. Okay? So essentially what we're going to do is we'll go ahead and we'll set up that coordinate plane again, and we'll also set that table up for you. I'm going to, again, work with the basic 5 numbers, again, because they're light and kind of easy to work with. So I would also set up the table as you had originally seen it in the parent function situation. So when you take a look at the -3, if it is on the outside of the function, this is a vertical shift. Specifically, you will either be moving up or down. We need to determine that. And a vertical shift is actually pretty straightforward. So if you see a -3, what do you think of when you think of a minus? Do you think moving up or do you think moving down? And hopefully you all are thinking, well, I would move down. So in this case, you are being told to move down 3 units. Well, if you're moving down, then which axis are you moving along? The x or the y? Well, the x and the y, the arrows on that one are indicating that the line is both going up and down. So if I'm moving down 3, I'm going to subtract 3 from all of my y value answers that I had originally gotten from my parent function. And then I'm just going to set up this new column for the new coordinate points that I've worked with. Notice the x values are not changed, but notice now 2 minus 3 will give me -1, 1 minus 3 gives me -2, 0 minus 3, -3, 1 minus 3 is -2, and 2 minus 3 is -1. So we will go ahead and plot those down. And there you have it. Compare the original function that I'm going to go ahead and box in green to the new function that I'm going to box in blue. Does it look like the same function, only you've moved it down 3 units? Okay, so this is an example of a vertical shift. Right. There will be another video that will follow shortly that I would suggest that you read through. This one will talk briefly about horizontal shifts.